So we are going to begin looking at how to prove trigonometric identities. But before we can do that, I had to just give you some basic identities that you will work with and kind of use as your building blocks in order to prove different identities. So we're going to just start with our basic identities, and then you're going to be using these in the problems to prove other things. First, let's just begin with what an identity is. An identity is an equation that is true for all values in the domain of the variable. And then when we're working with identities for this particular chapter, we're going to be using trigonometric identities. There are three types of identities that we're going to be using. There's the reciprocal, which when we talk about reciprocals with fractions, reciprocal is like the flip. There are quotient identities, and remember, quotient is like division or fractions. And then there's Pythagorean identities, and Pythagorean is going to look similar to the Pythagorean theorem that a squared plus b squared equals c squared. Let's begin with what the reciprocal identities are. These are related to the reciprocal trig ratios. So cosecant is equal to 1 over sine, secant is equal to 1 over cosine, and cotangent is equal to 1 over tangent. So we actually have already introduced these in a previous lesson, but now we're going to go ahead and claim them as reciprocal identities, and we can use them to solve other identities and to prove things. Now we have the quotient identities, and you can actually find how these identities were derived on page 458 and 459 of your textbook. The first quotient identity would be tangent. So tangent is actually the same as saying sine over cosine. And the way that works is because if you think about it, tangent is opposite over adjacent. And if you were to put sine over cosine, sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. So opposite over hypotenuse divided by adjacent over hypotenuse ends up being opposite over adjacent, which is what tangent is. So that's how it's proved to be true. So you'll need to know that tangent can be rewritten as sine over cosine, and sine over cosine can be rewritten as tangent. And then likewise, because cotangent is reciprocal of tangent, then cotangent can then be rewritten as a reciprocal, cosine over sine. Then we have our Pythagorean identities. So remember, these are going to replicate that a squared plus b squared equals c squared. So our first one is going to be that sine squared plus cosine squared equals 1. And then 1 plus cotangent equals cosecant squared. 1 plus cotangent squared equals cosecant squared. And then we have tangent squared plus 1 equals secant squared. So when you're proving identities, you want to choose one side of the identity to manipulate. You're never going to try to work on both sides, because then things will get messy and you're going to lose what you were trying to prove in the first place. So when you're proving identities, pick one side. And then you're going to use our basic identities that we just went over, and you're going to work with that side only, making substitutions and simplifying it until it looks like the other side. And once it looks like the other side, you're done. You proved it. So make sure that you don't apply any of the properties of equality to the original identity, because remember, you cannot manipulate the other side. And if you were to do that, you would be using circular reasoning. All right, now you might be ready to try proving some identities of your own. Definitely give it a shot and try your very best.